All right, this is an example of a Charles law calculation. Question we're going to work together is on slide 45 in our chapter 11 PowerPoint. States, helium gas is used to inflate the abdomen during laparoscopic surgery. Sample of helium gas has a volume of 5.4 liters and a temperature of 15 degrees Celsius. What is the final volume in liters of the gas after the temperature has been increased to 42 degrees Celsius when the pressure and amount of gas does not change? So we know this is going to be a Charles law calculation because the only two variables that are changing are volume and temperature. And so Charles law is V1 over T1 is equal to V2 over T2. So first thing we got to do is figure out what all our variables are and which one we're solving for. So the first part of the problem says a sample of helium gas has a volume of 5.4 liters. That's going to be our V1 and a temperature of 15 degrees. 15 degrees Celsius, that's our T1. And then the second part, we're looking for a final volume in liters of the gas when the temperature is increased to 42 degrees Celsius. So that 42 degrees Celsius, that's our T2, and we don't know what our V2 is. That's what we're solving. So for Charles' law, we can't just keep our temperature in degrees Celsius. This law only works when our temperature is in Kelvin. So to convert Celsius to Kelvin, we're going to use the fact that degrees Celsius plus 273 gives us our temperature in Kelvin. So we have to change both T1 and T2 to Kelvin in order to plug into this equation. So we're going to do 15 degrees Celsius plus 273 gives us 288 Kelvin, and then 42 Celsius plus 273, that's going to give us 315 Kelvin. So now we can plug all of our values into Charles' law. So our V1 is 5.4 liters. T1 is 288 Kelvin. Our V2, that's what we're solving for, and our T2 is 315 Kelvin. So in my experience, the easiest way to solve this, since we have basically a problem where we can use cross multiplication, is I'm going to cross multiply these to get the variables down and not into fractions. So we're going to get 288 Kelvin times our V2 is equal to, let me pull out my calculator for a second. I don't have this already worked out. Oh. This is real-time problem working for you guys. 315 times 5.4 gives me 1701. Alright, so now we can divide both sides by 288 Kelvin, and we get that V2 should be roughly 5.91, and that's in units of liters because our first volume was in units of liters. So there you go. There you have it. That is our final answer for this problem. Thanks for watching.